Welcome back, students. Today I'll tell you about nature of the roots of a quadratic equation. Now I have already told you that ax square plus bx plus c is equal to 0 is a quadratic equation where a is the coefficient of x square, b is the coefficient of x and c is the constant term. Now what we do, I told you using the Sridharajar formula, x is equal to minus b plus minus under root b square minus 4ac upon 2a. Using this formula, you can easily find the values of x. Whenever we solve a quadratic equation, we get two values of x. So here also, if you take plus sign, you will get one value. If you take minus sign, you will get another value. Okay? Now, this b square minus 4ac is called the discriminant of the equation. It is called the discriminant of the equation. Now, first thing, if b square minus 4ac is greater than 0. Greater than 0 means it is positive. That means the discriminant is positive. If b square minus 4ac is greater than 0 means it is positive. In that case, whenever we have a positive number inside a square root, we get a real number, and minus b plus something and minus b minus something are two different values. That means the two values of x will be real and they will be distinct, means different. Clear? So, and definitely as the square root is there, so the numbers are irrational. You know, a number, the numbers with square root are called irrational numbers. So, roots are real, distinct. Distinct roots are also called unequal roots. Real, distinct and irrational. So without solving the whole equation, just by seeing the discriminant, and if the discriminant is positive, you can say that the roots are real, roots are distinct, means different, and they are irrational as square root is there. Clear? Now the second one, if b square minus 4ac is equal to 0. Now if b square minus 4ac is equal to 0, that means first thing the square root vanishes because there is a 0 inside the square root. So definitely the remaining portion will be real. When square root is not there, the remaining portion will be real. And minus b plus 0 and minus b minus 0. Things are, they are same, na? Minus b plus 0 and minus b minus 0. So the things are same, so the roots are equal. Here distinct roots are not there, roots are equal. And now they are rational because the square root is not there, so rational. So now you will write roots are real, equal and rational. Roots are real, equal and rational. Is it clear? If this quantity is 0, that means plus 0 or minus 0 remains the same. That is why roots are equal. No square root is there, so the roots are real and equal. And as the square root is also not there, so now they become rational. Clear? Now the third part. If b square minus 4ac is less than 0. Now see, When b square minus 4ac less than 0 means b square minus 4ac is negative. Now whenever a negative number is there inside square root, they give you imaginary value, imaginary answer. I repeat, square root of any negative number is not real, it is imaginary. So that is why when b square minus 4ac is less than 0, so simply you write roots are imaginary. Roots are imaginary. Clear? When the discriminant is negative, means less than 0, that means within inside the square root we will get a negative number, so the roots are imaginary. Clear? And fourth one, if b square minus 4ac is greater than 0, same as the first one, and b square minus 4ac is a perfect square number. B square minus 4ac is a perfect square number like 36 or 49 or 64 or 81. If b square minus 4ac is a perfect square number. Now see, if b square minus 4ac is greater than 0, same here, roots are real. So you write down roots are real. Distinct, so you write down distinct. And it is irrational over here, but inside square root, if 36 is there, we don't write root 36, we will write it 6. Or inside square root, if 81 is there, we don't write root 81, we'll write it as 9. If inside the square root we get 144, we don't write under root 144, we'll write it as 12. So that means now square root goes, so now it becomes rational. Instead of irrational, it becomes rational. Clear? So now I repeat, there are 4 conditions. When b square minus 4ac is greater than 0, then roots are real, distinct and irrational. When the b square minus 4ac is equal to 0, roots are real, equal and rational. If b square minus 4ac is less than 0, roots are imaginary. And if b square minus 4ac is greater than 0 and b square minus 4ac is a perfect square number, in that case roots are real, distinct and rational. That is the main thing. These are the nature of roots based on the value of the discriminant, that is b square minus 4ac. And now we will do few questions based on it. First question, find the nature of roots of 2x square minus 4x plus 3 is equal to 0. 2x square minus 4x plus 3 is equal to 0. Compare with ax square plus bx plus c is equal to 0. Compare with ax square plus bx plus c is equal to 0. Then a is equal to 2, b is equal to minus 4, c is equal to 3. Discriminant is equal to b square minus 4ac is equal to minus 4 square minus 4, a is 2, c is 3. Now minus 4 square is 16 minus 4 3 is 12, 12 into 2 is 24 and 16 minus 24 is minus 8. Now you see b square minus 4ac is negative, means less than 0, as b square minus 4ac is less than 0, so roots are imaginary. Roots are imaginary. When b square minus 4ac is less than 0, then the roots are imaginary. Clear? That is your answer. Next question. X square plus 7x minus 60 is equal to 0. Now this is the quadratic equation and you have to find the nature of the roots of this quadratic equation. So what we do, compare with ax square plus bx plus c is equal to 0. A is equal to 1, B is equal to 7, C is equal to minus 60. A is equal to 1, B is equal to 7, C is equal to minus 60. Now discriminant that is b square minus 4ac, that is 7 square minus 4 into 1 into minus 60. Now see, 7 square is 49, minus into minus plus, 60 into 4 is 240, 240 plus 49 is 289. Now 289 is b square minus 4ac is greater than 0, means positive, and you can see 289 is a square of 17, so it is a perfect square number also. So now I think it is the fourth case, b square minus 4ac is greater than 0, so roots are real, distinct and rational. That is your answer. Why rational? Because the discriminant is a perfect square number. 289 is a perfect square number. That is why it is rational. Roots are real, distinct and rational. Next question. 3x square minus 2x plus 1 by 3 is equal to 0. You have to find the nature of the roots of this equation. Now to avoid the fractional part, first of all you multiply the whole equation by 3. So 3 into 3, 9x square, 3 into 2, 6x plus 1 is equal to 0. Compare with ax square plus bx plus c is equal to 0. A is equal to 9, b is equal to minus 6, c is equal to 1. Discriminant b square minus 4ac, that is minus 6 square minus 4, a is 9, c is 1. Now minus 6 square will be 36, minus 36, that is 0. Now you can see here the discriminant is 0, that is the second case. The roots are real, rational and equal because the discriminant is 0. As b square minus 4ac is equal to 0, so roots are real, equal and rational. That is your answer. Roots are real, equal and rational. Clear? Next question. Two x square minus 3x plus 5 is equal to 0. So first of all you have to find the nature of roots of this quadratic equation. So compare with ax square plus bx plus c is equal to 0. Compare with ax square plus bx plus c is equal to 0. Then a will be equal to 2, b is equal to minus 3, c is equal to 5. A is 2, b is minus 3, c is 5. Discriminant that is b square minus 4ac, that is minus 3 square minus 4ac. Minus 3 square is 9 and this is minus 40, so it is minus 31. So you can see the discriminant, that is b square minus 4ac, is negative, means less than 0. You know when the roots, when discriminant is less than 0, then the roots are imaginary. So you simply write as b square minus 4ac is less than 0, so roots are imaginary. Okay, imaginary roots are there. That is your answer. Next question. Three x square minus 4 root 3x plus 4 is equal to 0. 3x square minus 4 root 3x plus 4 is equal to 0. You have to find the nature of the roots of this equation. Compare with ax square plus bx plus c is equal to 0. A is equal to 3. B is equal to minus 4 root 3. C is equal to 4. Now discriminant, that is b square minus 4ac is equal to minus 4 root 3 whole square minus 4ac. Now you see, minus square is plus, 4 square is 16, root 3 square is 3. 16 into 3 is 48. And here 4 4s are 16, 3s are 48. And 48 minus 48 is 0. You know, when the discriminant is 0, that means the roots are real, equal and rational. So as b square minus 4ac is equal to 0, so roots are real, equal and rational. Okay, the roots are real, equal and rational. Now we'll check this answer by solving the quadratic equation here. So what we do, you see a is 3, b is minus 4 root 3 and c is 4. So using quadratic formula, x is equal to minus b plus minus under root b square minus 4ac upon 2a. X is equal to minus b plus minus under root b square minus 4ac upon 2a. Now what we do, minus b means minus of minus 4 root 3 plus minus under root, we have just solved b square minus 4ac here, so I have written directly 0 upon 2a means 2 into 3. Now what happens, minus into minus plus, so it is 4 root 3 upon 6, because root of 0 is 0, plus minus 0 remains the same. Cancel it by 2, so it is 2 root 3 by 3 comma 2 root 3 by 3. So you can see both the values of x are same, they are definitely real, and although I have written rational here, but as already the value of b is irrational, so this number is irrational because root 3 is there. Otherwise, due to under root b square minus 4ac, we are not having the root. That b is already in root, so here we can say that it is irrational because square root of 3 is there. Clear? That is your answer. Okay. Next question. Question is, two x square minus 6x plus 3 is equal to 0. you have to find the nature of the roots of this equation. So compare with ax square plus bx plus c is equal to 0. So a is equal to 2, b is equal to minus 6, c is equal to 3. Discriminant b square minus 4ac, that is minus 6 square minus 4 into 2 into 3, 36 minus 24, that is 12. Now, as the discriminant is positive and the discriminant positive means greater than 0, so the roots will be real, distinct and irrational. As b square minus 4ac is greater than 0, so roots are real, distinct and irrational. So once again we'll check our answer by applying the quadratic formula. So you write using quadratic formula, x is equal to minus b plus minus under root b square minus 4ac upon 2a minus b, that is minus of minus 6, plus minus under root b square minus 6 square minus 4, a is 2, c is 3 upon 2a, that is 2 into 2. So minus into minus plus 6 plus minus root 12, we have just calculated is 12 upon 4, 2 into 2 is 4. Now you know root 12 can be written as 2 root 3 because 12 is 4 into 3, so we can write it as 2 root 3 upon 4. Take 2 common, so it will be 3 plus root 3 upon 2 and 3 minus root 3 upon 2. So you can see we have two roots, they are real, they are distinct and they are irrational. That is your answer. Clear? So in the next class we will do few more sums based on nature of roots.